All right, let's go. It might surprise you, but this is the last day of November. There's nothing interesting here. Nothing's changed, so I'm going to update this. Okay. Yeah, that was the self-assessment was now, so hopefully you turned that in. No class on Tuesday. Thursday is the optional in-class final. Are any of you planning on taking that? So people don't really view it as being very optional. But have any of you looked at the sample that I put on Piazza? Nope. Okay, I put a sample of what the exam is going to look like on Piazza. No one's looked at it. Great. Okay, well, there's a sample on Piazza. You looked at it. Scare you? I mean, it's only 50 pages long, right? I could make it a little bit tighter, but whatever. The last time I did this, I had people actually mark the answers on the individual pages. That was why I ended up putting one question per page. This time I put an answer sheet at the back so that you can put the answers on an answer sheet and I can scan those instead of the entire physical test. Save me a lot of time. I'll only have to scan 110 pages. Nothing else has changed here. Oh, I didn't take anything out of the slides that I just stole, so there's no readings for this, obviously. I would strongly recommend that you look at the sample final on Canvas. It will give you an idea of what next Thursday. I have not yet put the answer key up, but you will see the answer key. I was thinking of putting it up on Monday. That way you have the weekend to look over the exam without the temptation of looking at the answers in advance. Because I know everybody will want to see the answers eventually, but if you have the answers and the original at the same time, there's going to be this temptation to just look at the answers, and I don't think that's quite as useful. Day's failure, I just simply said, oh, I need to go grab a failure. So I grabbed this failure from the register, which was published yesterday. And a cloud company called Rackspace is now being called euphemistically Lackspace because their customers are unable to access their files due to a shortage of space on their storage services. So here we go, another interesting example of a basic failure. Yes, storage is cheap, but it isn't infinite. And those darn customers will use it. You know, this reminds me of one of my favorite sayings, which is, this would be a great business if it weren't for the customer. That's like a dad joke, right? I don't know, have you ever gone to like a shop or a place where people treat you like they wish you weren't there? That's exactly that attitude. Boy, I really would like this job if it weren't for these damned customers. Very pesky. Okay, so Rackspace tried to add some space, but it didn't work very well, yada, yada, yada. So I thought that was a very nice, simple example of a failure. Some of these failures I've given you are pretty complicated. This is not a complicated failure. This is a simple failure. However, it's not necessarily an easy-to-fix failure. They added some storage, and their customers immediately consumed that storage. Ah! It takes time to add further resources. If you're running your own cloud storage division, you have to be aware that you have to have capacity. You have to constantly be planning ahead for these things. But we live in the real world where maybe you're not going to get all of the extra storage that you expected because there's a supply chain problem. So if you were in this situation, this would make a great scenario actually. If you're in this situation where you don't have enough space, what kinds of solutions would you suggest that you take, that you could implement in a short period of time? I might actually put this as a question on one of these finals because this is great. I like this question. Over here. Rackspace can buy resources from another cloud service provider. There you go. Boy, that one's going to fly really well with management. Okay, you could actually do that, right? You could outsource it to somebody else. Decrease your replication factor. That's actually an interesting idea. Oh, crap. Well, what could we do to decrease our replication factor? We didn't go into it in detail in this class, but there are, in fact, entire schemes and whole papers about how to decrease the amount of storage space we need for replication. They utilize what are called erasure codes. I have used the term erasure codes. I don't plan on putting that on the final because it's not something that we went through in very much detail. But there are techniques and methods that are available to us that allow us to preserve space, to use less space without giving up the benefits of replication. At a company like Amazon, how much money do you save if you can reduce your storage requirements by 20% without reducing your replication factor? Enough to earn a really big bonus. Like the company saves $500 million and we're going to give you a $20,000 bonus. Thank you very much for your hard work. I'm not quite kidding. Actually, at Amazon, you can get pretty good bonuses for saving far less than that. So the big cloud players do actually reward this kind of thinking. You're not going to get anywhere near what they save, but of course, you're still going to get something as recognition there. So yes, it's a good question because it's a basic failure case that you might actually hit in the real world. A couple of weeks ago, I gave you an example that somebody from the last class I gave said, oh yeah, our company found that we were getting hit by so much traffic that our replica was falling behind, and they were using transactions, right, to keep the replica in sync. They were falling behind, and so they started failing transactions coming in from clients. And they had to solve that problem. I even mentioned what their solution they were looking at was, but I'm curious, if you were going to solve this problem, what would you look at doing? When your database can no longer sustain the load, we have talked about this. We've talked about this at great length. When your database can no longer sustain the load that you're asking of it, what do? Get rid of some customers, right? Because that's exactly what management wants to do. Pesky customers, get rid of them. What are you going to do? And what do we call that? Right. Partitioning. We are going for vertical scaling. I'm sorry, horizontal scaling, not vertical. What is vertical scaling versus horizontal? I mean, it depends on whether you're laying down or standing up, obviously, but. Right, exactly. You decide that you're going to go out and buy an Ampere system with 384 cores. Speaking of failures, it turns out that Linux doesn't support 384 cores. You have to rebuild the kernel. There is an option that will let it work, but you have to rebuild the kernel. It doesn't work out of the box. And I know that's what I want to do when my $5 million 384 core system shows up. I want to rebuild the Linux kernel first before I can even deploy the thing. Has anybody heard of the Ampere systems? What's an Ampere system? Yeah, Ampere are ARM, 196 core ARM processors. Why you get 384 cores when you have two physical CPUs. Each one has 196 cores, and each core has 2 threads. So that is a lot of processing power. Who could possibly need that much processing power? Well, I know. I mean, maybe you're using some of those games out there that benefit from that. Anybody game? What's the secret to getting really good performance out of a game? Anybody know? Money. Well, yes, but money, and what are you going to spend that money on? Smaller windows. Smaller windows make things faster. Interesting. Okay. Any other ideas in the back? Run the game locally. Okay, so you're playing a competitive shooter game, and you're going to bring all of your shooting friends. And people do that, right? They literally have like everybody gets together and then they run a private server. Great. Okay. Other ideas? Go ahead. Sorry. By a faster GPU. Actually, it turns out GPUs often don't solve the problem. Very interesting, but it might. Depends on what the bottleneck is. This was related to the Ampere question, so in fact, it's a CPU question. I'm kind of curious to see. Right, and what makes a single thread performance higher? Frequency, right. So the reason that people like to overclock their CPUs in the gaming world is because overclocking the CPU makes it run faster on a single thread, which means the game runs faster on a single thread. Most games are not multi-threaded. Most games end up using a single core, a single physical processor to actually run, well, a single physical core actually, to actually run the GPU. Because you have to feed the GPU all of the stuff it needs in order to render the video. If your video card is your bottleneck, absolutely. Getting a better video card will do it. But what you find out is that often you get a better video card and then it doesn't really actually bump it up that much. And that's because now the CPU is slacking. But go buy yourself an Ampere, right? Because it's not going to help. You don't need 196 cores. What you need is like 4 blazingly fast 6 gigahertz cores. And there are gaming machines that do that actually bump up the CPU's frequency. We've talked about one of the problems with computers, and it's kind of related to this. Can you take a stock CPU and increase its frequency? Can you overclock it? Anybody ever overclocked a CPU? What is the secret to overclocking a CPU successfully? Don't overdo it. And what does overdo it mean? What happens when you bump the frequency of the clock up? It doesn't boot. Well, that's what happens if things go wrong because you're not doing what you need to do. You need to remove the heat. An increase in frequency causes a significant increase in the amount of heat output. The reason that we went to parallelism rather than increased frequency is because parallelism doesn't have the same thermal loading behavior as increasing the frequency does. So what overclockers do is they put better cooling units on the CPU. If you really want to get to an extreme, what you do is you take your CPU and you keep it in liquid nitrogen. Wish I could say I was joking, but in fact, IBM built an entire line of computers around these liquid nitrogen cooled processors. If you want a high frequency CPU, you buy an IBM mainframe. That's actually how IBM mainframes end up performing extremely well. They run like between 6 and 7 gigahertz. But cool failure kind of led me on a wild goose chase, but I don't have much to talk about today anyway. So I'm going to talk a little bit about the in-class, optional in-class final. Nothing's changed here. I just stole the slide from the previous time I used this. It is 1 week from today. By this time, a week from now, those of you taking the optional in-class final exam will be partway through it. I don't actually expect it will take 75 minutes, but I know the material. I created the exam. So for me, it would be like, how hard could this possibly be? I can assure you it took a lot more than 75 minutes to create the exam. Of the one person in class who said they'd actually looked at it, what did you think so far? Oh, we only looked at a couple of them. Okay, anybody else look at it? Some people have trickled in afterwards. No one's looked at the sample exam on Gaza. Oh, just skim through it. How about you? What did you think? I mean, what's he going to say now, right? You know, I know who he is, so he doesn't want to say anything too bad, or otherwise I might change the grade on him. But no, I mean, it's not really focusing on you remembering details. It is really focusing on you understanding concepts, which makes it hard. It's way easier to just memorize, you know, the multiplication table and go in and regurgitate it. But at the same time, I told you up front, that was what I wanted you to walk out of this class with. So that's me measuring how well I did my job. Because that's the way I look at it, is that I'm going to look at what you guys do on these exams, and I'm going to say, how well did I impart an understanding of these principles? I know you're looking at it as like, I don't care. I just want to get a good grade on it. But the idea is, I'm still clumsy. The idea is 5 scenarios, 4 true or false questions per scenario, 4 multiple choice questions per scenario. Now, in fact, when I generate the actual tests, I haven't finished this yet, but my goal is to have 10 scenarios and 8 true-false questions and 8 multiple choice questions per scenario, and then each of you will receive an exam from which 5 of those scenarios are drawn, 4 of those true-false questions, and 4 of those multiple choice questions. And if you want to do the combinatorial analysis on that, I can tell you that the likelihood that anybody has the same exam is 0. And I was doing math this morning going, okay, let's see, well, could I get away with doing 6? Nah, 6 doesn't really do it. And even if I go to 8, birthday paradox says that there's going to be 2 people who basically have the same exam. So you have to increase the diversity. It's kind of an interesting analysis. Part of this is I'm trying to keep the questions relatively comparable, the scenarios relatively comparable, and the questions of relatively equal difficulty. And so when you walk in, hopefully I'll have some other people to help me. I'll have the exams sorted out by your name, not your student ID number. Everybody gives me their student ID number, and I go to Canvas, and it's like it tortures the damned finding people by ID number on Canvas. In Gradescope, give up. But by name, easy. Very interesting. There must be some tools here that are really emphasizing that student ID number. Be that as it may. You'll receive the exam. There will be an answer sheet at the back. I want you to fill out the answer sheet. It will have your name and your exam number on it. And I think I was going to put a signature on it. I don't think I put that on the sample, but I will probably do that. I don't know why. Just because that way you can sign it and feel like I'm official or something. And what I'm going to do then is take those answer sheets, and that's what I will scan and grade against, because based on the exam number, I can figure out what the correct answers were for your exam. Oh, and when you're done, I will hand you your personalized answer key. Walk out the door with a copy of your exam and the actual correct answer. I mean, honestly, if you want to keep the original exam, you can mark down what you answered and then you compare it yourself. You can keep me honest to make sure that I didn't screw up in the grading. Fine, as far as I'm concerned. So, scenarios are intended to be representative, high level, a little hand wavy, but representative of real world situations. I mean, I particularly liked the low Earth orbiting content distribution network scenario. I had fun with that because those types of situations change the way that you think about the problem. There are a couple of questions on there that are actually pretty difficult because it's not obvious unless you really think about what the question is asking you, what the right answer is. Since nobody's really looked at it, I can just go grab a copy and kind of show you a little bit about the scenarios. Da, 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 da. So this is roughly what it's going to look like. That's the first page. It's got lots and lots of random text on it. I used to put, well, the first time I did this, I put the signature on the front page. I think I'm going to put it on the back page. I'll show you the back page. So this is what the answer sheet looks like. It'll actually have your name and ID number on it. It doesn't here because this is, I have an option to create blank exams in case I end up with a spoiled exam, for instance, or I need to demonstrate a sample exam. Let's see, what else? Boring, 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 boring. Yeah, right, blah, blah, blah. So during the exam, no electronic devices, unless they're pre-approved. So if your pacemaker is going to be an issue and you need to adjust it, or your insulin pump, or something like that, fine, that's okay. No phones, no pagers, no scanning electron microscopes. One page of notes, both sides are fine. Write as tiny as you want. Don't get to use a magnifying glass. I know, crushed, aren't you? That's why I had to ban the scanning electron microscope option, because somebody would. They'd be going, well, I happen to have one in my my garage, so I just etched it on a piece of aluminum foil and I brought it in, and now I'm going to read it. Because you could get all of the entirety of all of these books on a piece of metal foil easily. Problem, of course, is searching it, right? That would be hard. Question? In fact, the purpose of the answer sheet, maybe you've never had an instructor tell you this before, but most people end up finding the answer sheets don't actually help them. The purpose of the answer sheet is that it causes a reinforcement pattern in your own brain. When you walk into the exam, you have a better understanding of the concepts and the material. So it's really a learning tool, but not especially useful, especially in this kind of an exam, which is part of why people are like, oh, is it one side or two side? I'm like, honestly, I don't really care. I mean, I could, if you want, I can let you bring in 2 pages, and I don't think it's going to make any additional difference. Instead, what makes more difference is for you to go through and say, what were the important things in each of these sections? When I look at the scenarios, this is why I'm giving you the practice exam now. Go through those scenarios and say, would I be able to answer this question based upon my recollection of what was there? If not, I better go look and see what I'm missing, because this is a sample of what is going to be expected. But odds are I'm going to end up throwing some scenarios in there that we talked about, but may not necessarily be covered in the practice exam. But there's really only a handful of key concepts here, right? We keep hammering on them. Consensus, consistency, transactions, networks, unreliability, replication, sharding, failure, failure detection. And I've walked through this list like a dozen times, and I still have to think about it every single time. I mean, I have literally talked about these things over and over again. What a nice little picture. I got, while I was on the way in, I was sitting there using DALL-E, and I said, give me a picture of a Paxos that looks like, it's a hopper in the front where lots of things come in and a linear ordering of things come out the other end. And then I played with that a little bit, and I got one that I liked a little better, which was it had multiple hoppers with different different colors, and then you could see that for a while you had different colors coming out the other end, and I'm like, that feels like leader change, doesn't it? You know, because you have leaders proposing things, and so you get a stream of these leader changes, and then you can see, I even liked the fact that there was one point where there was one color, then a different color, then back to the original color, and I'm like, that's perfect. It's exactly the kind of behavior that I'd expect to see in a Paxos-based environment. I spent a lot of time talking about Paxos. And part of the reason is because Paxos is really difficult to understand when you first look at it. And I've gone over and over and over it. Paxos doesn't solve every problem, does it? In fact, the conversation on Discord while I was on the way in was exactly that. What problem does Paxos solve? That's why I wanted the picture. And the point, I think that's the question I was talking about, because I put a picture there after that, unless there's been a follow-up question. The point is, Paxos doesn't solve the problem of data propagation. It solves the problem of linearization of operations. The only entity that knows what the linear order is at the moment that a Paxos decision is reached is the proposer. If we have a leader, that leader is the distinguished proposer, but it's just the proposer. The only one who knows at the moment it's actually adopted is the proposer, because the individual acceptors know that they've accepted it, but they don't know what anybody else has done. What does the proposer do when it has an acceptance? Do you remember? He sends a message, he says, hey, this is accepted. What we often do in the actual implementation is we send another proposal, and that implicitly acknowledges the previous proposal has been accepted. Maybe I'll piggyback two of them. Why would I combine two messages into one? It's an optimization. The thing that drives you crazy about these protocols and trying to understand them is that people optimize them. That is what I hate about PMMC. That's why I don't actually like that paper, because it's teaching you its optimized protocol. But when you are trying to understand the protocol, it's important to understand the unoptimized protocol and then introduce the optimization. It's a lot easier to say, oh, of course, two messages. I send this one, then I send another one. Why don't I just piggyback and combine those? So I spent a lot of time. You had a question or? Paxos guarantees linearization of the operations. It doesn't guarantee that they propagate to the learners instantaneously. Because when a client asks for what's in the database, the learners are the database. Paxos is the linearization layer. So the hopper of operations comes in, the decisions come out the other end in a linear order, and we propagate that linear information out to the learners. Lamport talks about ways of getting that data out quickly. I actually talked about this in one of the lectures. I spent the whole lecture just talking about how we get that data to the replicas. Right. If you want everyone to be able to see that operation is finished, you have to use transactions. You cannot use Paxos. No. Its linearizability is just that we have a single order of operations that everyone will use. But that doesn't mean they've used it yet. There's a propagation delay problem. That was why I said, when I'm the proposer, I know what the decision is. I happen to be co-resident with a learner. Who's the first learner that happens to find out what my decision was? My co-resident copy. But what about the guy over there who hasn't heard about it yet? He gets a call from a client. The client says, yo, hello, what's the value of that key? He hasn't heard that this was changed, so he says, well, here's the value in my replica. If you want stronger consistency, what he has to do, and you did actually mention this, what he would have to do is a quorum read. Because in a quorum read, that's interesting. That doesn't actually guarantee it, right? Let's say there are 3 copies. He's one of the 3, you're one of the 3, and Lord, I know she's one of the 3. We have to have some diversity in here. Those 2 have the old data, you have the new data. They form a quorum across a read. And so you're not going to get a consistent read at that point either. But here's what's kind of weird about this, is that we have the propagation delay essentially creates a scenario in which either answer is correct. That's the way I think of it. Until everybody has the same copy of the data, we don't know the ordering of your change relative to their read. So they could have their read could have come in before you reached that Paxos decision, or they could have been after you reached that Paxos decision. They are within that area of uncertainty. You remember when I talked about Google Spanner? What they did was they delayed answering the client for a period of time. And that was because they guaranteed that they would know within that time frame. Right. Why is it a contradiction? Paxos agreed on what the order of those operations are, but the replicas are not updated. If you want to guarantee the replications are updated, you have to use transactions. That's really the only way to do that. That's why we actually don't end up using transactions. That's why consistency is a bitch in these systems. Because literally, if you're sitting there using real transactional guarantees, one database goes down and you're screwed. And so we end up using a combination of those things. Let's see. So what could we do? So we have this period of inconsistency. How could we close that? That's a really good question. Enough of the replicas may not be up to date that if we, okay, so there is a way to fix this, and that's what I'm trying to get to. PMMC does this. And that is, if I get somebody asking me what the value is, and I see something in my log that says I have an outstanding proposal for that, I will wait until I have an answer on that outstanding proposal before I respond to that client. That, combined with quorum read, will give you strong consistency. Is there? Mm-hmm. Right. Well, right. So there was remember, one of the techniques that we used was when you got a read and we weren't sure if we had the current value, we'd go fetch it. Right, exactly. So we would go fetch that value, and then we give the client the current value. The problem here is the definition of when something happens, because the whole idea of isomorphism is that things that are not causally related, we can't tell the order of them. Your request and somebody else's attempt to change the key are not causally related at our level, at the key value store level. If you want to guarantee that causal relationship at a higher level, you build a transactional layer on top. That's actually how we're going to solve this problem. That's why in Design Project 3, what we did was we built a transactional layer on top of a Paxos replicated key value store to allow us to move data between shard groups. I know most people probably ignored Design Project 3, but in fact, Design Project 3 is the interesting one because it actually solves some of these problems by using both a combination of two-phase commit along with Paxos-based replication. And it's a PMMC implementation, so they actually they serialize the client reads. And client read here means if I'm doing a quorum read, I'm just a client. As far as the other replicas are concerned, I'm just a client. So I read enough of those, and I know that at least one of them will have voted for the new value, therefore it will have an outstanding proposal, and it will sit there and wait. If I can find a subset, any subset, that hasn't seen the proposal for that new value, I got a quorum. I'm done. That means that hasn't been adopted yet. And that's the power of quorums. That's why we end up falling back to quorum analysis repeatedly. I didn't talk about it in this class, but I've talked about quorum consensus over and over again. Dave Gifford, 1979, presented a paper at SOSP about read-write quorum consensus. That was, in essence, the way that we broke out of the two-phase commit world. Because two-phase commit, strong consistency protocols, which guarantee this without any extra, well, no extra work, but they're just slow, had been around for at least a decade by that point. The distributed database people have known how to do two-phase commit in a distributed transaction, distributed database world for a long time. What he came back with is he said, well, you know, it's slow, it's expensive, and it's cumbersome, and here, this allows us to get the same level of guarantee, even if there are some failing nodes. So we can keep making forward progress. So what was he trading? He was trading complexity for availability. Because this is a much more complicated algorithm. Getting everybody to agree on where to go to dinner is way easier than trying to get a consensus and then just going and hoping that everybody else will follow you. Does that make sense? These are really fine-grained and important details, but they really do sit at the heart of this. If you want strong guarantees, Paxos by itself doesn't give them to you. You have to have something beyond Paxos once the linearization is accomplished in order to ensure that the clients are getting the latest decided value. A quorum read will do that if you block reads against any outstanding proposals in your queue. Does that make sense? You don't know. You don't actually know what's happened between those 2 points, right? You don't know what the state of the system is between those two because you actually don't have a global observer. No, linearizability just guarantees on the order in which the operations are going to be performed. To add a real-time aspect of that, you have to actually have a quorum read or some other mechanism for ensuring that the data has been updated at the replicas so you can guarantee that you're giving it the current value. No, I don't think so. I'm not sure. Okay, so linearizability means that, so linearizability is the idea that we have a specific sequence of events, whereas sequential consistency just means we have an isomorphic sequence of events, or set of isomorphic sequences of events that are equivalent. So the linearizability is the one out of the set of sequentially consistent runs. So I can move these pieces around and they end up with exactly the same set of results. That's the sequential set, and one of those is the linearized set. And all Paxos is doing is picking that one path of the linearized set to ensure that every replica performs the operations in exactly the same order. We end up using sequential consistency because it allows us to fudge things when we get into eventual consistency, right? Because, yeah, maybe I went this way, or maybe I went that way, or maybe I went this other way, but I always ended up at the same spot. So it doesn't matter how I got there. Whereas in replicated state machines, the only way I guarantee that my state machine actually works correctly is by feeding it the same exact input in the right order. They're like different techniques of accomplishing similar tasks. I talked about Anna, the eventually consistent replicated key value store that they did at Berkeley. It's a really cool system about the way it scales from a single node all the way up. And they're using specific data structures that are sequentially consistent. And eventually, they reach eventual consistency because they have sequential consistency, because the operations can be done in different orders. Thus, it's not linearized. They can be done in different orders, but they come up with the same output, the same result. Does that make sense? That operation, okay, so as far as Paxos is concerned, that operation finishes when the decision has been made. But that doesn't mean the replicas know that it's been finished yet, because that happens when all of them have received that decision and have applied it to their database. So it's that gap between when the proposer accepts it and the learner learns it that is this area, because I talked about how do we make that happen faster? So Lamport says, well, we'll just put the learners and the proposers and the acceptors on the same node. And that way, when we get a decision, the learner immediately knows and can apply it to the database. And so therefore, we end up getting a very small kind of propagation delay problem. If that's still not strong enough consistency for you. In other words, the client calls in this window where it could have been either answer, in which case you just say, good enough, I'll just give you either answer. But if you need stronger than that, you need strong consistency in that model, you have to add an extra layer on top of that. This is, okay, I need to do a quorum read. It's not good enough that I read from just one of the replicas. I need to read from a quorum of the replicas so that I can guarantee, and then the replicas have to look and say, is there anything outstanding? And if there is something outstanding, I have to wait until that's decided before I can answer. And that way I can guarantee the right answer. Now, here's the weird thing. Let's suppose that we have 3. The scenario I painted earlier, we have 3. You're the one you were the proposer, you just decided that this has been accepted. The other 2 have, so that doesn't work in this example. Let's see, what do we do? Make it 5. You've sent the proposal out. One of them has accepted it. 3 of them have not accepted it. If I do a quorum read from all 5, 2 of them are going to block and wait because they're waiting for an accept on this. 3 of them are going to answer, so what I'm going to get back is the answer from the 3 that still have the pre-decision value, and that gives me what I want. Alternatively, let's say one of those nodes is down, so it's 2 and 2. I'm only going to get 2, and I'm going to have to wait until the third one responds. At which point, I'm not going to get the same answer, and so I'm going to have to ask again. I'm going to have to keep asking until I can get a quorum. That keep asking should be pretty rare, and that is in fact the whole reason these systems work at all. So let's see. The first scenario was a distributed key value store. You won't be able to read this. I'll try to make it bigger and see if maybe I can. There we go. Can you read that? Okay. It's in that beautiful computer modern font that LaTeX loves, stores. The format for the design questions, the design scenarios, will be the same for the December 22nd final as it is for the optional in-class final. So it's really asking you the same thing. What I'm doing, though, is probing you in a slightly different way. So the optional in-class final is really probing more the breadth of your understanding. And then when you get to the in-class or to the official final on December 22nd at 7 p.m., I'm looking for depth. You're going to be presented with an option of one of 5. You're going to be given 5 scenarios to choose. You only choose one, but you're going to choose to go deep on that. So one looks for breadth of understanding in a variety of scenarios. The other one looks for depth of understanding. And that way I can evaluate things, since most everybody said they're going to take both of them. I can evaluate you on either of those. So hopefully one of those is more comfortable for you, and you can say, oh, I'd much rather be deep than broad. I'd much rather really focus on solving this particular problem in some clever or interesting way. Or I'd really prefer not to have to like deep dive in a 2.5-hour long exam designing this thing. I'd much rather just answer some questions about a variety of different design scenarios. So this one was distributed key value store, mixed read-write workload, scale horizontally across multiple nodes. So we're going to have some Paxos probably going on in here. I had to get at least a little bit of the database-y stuff in there, so I got some indexing into the design scenario. Caching. I haven't talked a huge amount about caching, but nothing here should come as a surprise because this is all standard system stuff, LRU caching and FIFO caching and whatnot. We did talk about transactions. We talked about replication. We talked about sharding, partitioning, same thing. In fact, I went through both Petrov and Kleppmann on sharding and replication. And there you go. And then, so this design scenario shows up on one page. Each question has its own page. I'm trying my best to kill as many trees as possible. Death to trees. If only I could get hemp-based paper, and then that wouldn't be such a problem. Hemp, yeah, they make paper out of hemp as well. Actually better than trees, environmentally. So you get a question, it's true or false. Either the statement is true or the statement is false. In the key value store, using log structure merge trees instead of B trees for storage would reduce read amplification due to preferring sequential I/O patterns. Either true or false. You're going to see questions like this. The way that the actual test generator works is that I have 2 statements. One's true, one's false, and it randomly picks one or the other. Go see, that's another true false one. There we go. Probably make the numbering match up. I have numbers here, and I think in the answer sheet I have letters. So that. So in the context of replication, distributed key value store, which replication model is typically associated with handling replica inconsistency more effectively? Kind of what we were talking about. Multi-master, master-slave, oops. Tried to change all the master-slave examples to primary backup. Leader-based synchronous replication, or nothing too fancy there. But give you a general sense of the kinds of questions they're going to be. Same thing. Let's go look. There's 4 and 4. And then we'll have another design scenario. Again, scenarios fit on one page. I think I shared this one. Yes, so we have this new company, Space Y, which is going to use a series of low Earth orbiting satellites for doing content distribution network. And our CDN is focusing on read-mostly data replication with consistency requirements, because mostly it's like kind of the equivalent of TikTok videos, which nobody cares if it's like seconds out of date. Well, you're going to have some data replication going on the globe. You have some geo replicated data, but then you're also storing data in this satellite-based CDN. Now, this is pretty much kind of a, I don't know, it's a little bit of a contrived example, but maybe I could make it more interesting by saying that the entire database is only satellites. That could make it more interesting. Well, we have interesting latency issues here. We have environmental issues. Oh, it's really stormy out, so I can't talk to the satellites. We have potential issues with the satellites themselves. The nodes fail. Boy, when they fail, they really fail big time, right? We have to launch another truckload of them up there and get them back into orbit in order to replace the failed nodes. We have latency variability, weak consistency requirements, interesting failure modes, bandwidth limitations, because as much as SpaceY wants to tell you that you're going to get 100 gigabits a second, the reality is you're not. We have dynamic topology. These nodes are literally moving around. I had some really cool questions about like energy constraints too, but I can't use those because we didn't really talk about energy consumption. That would be a little unfair. Another scenario. And you can see these are different. They are attempting to be real world scenarios, but they're all different. So I'm trying to get you to think about this because I have no idea what you're going to be doing a month from now. You know, some of you are probably going to be like out learning how to be baristas. It's a noble trade. You can hang out with the actors. The difference is the actors are going to be there in 10 years and you won't be. Maybe you'll do really well. You'll be in management at Starbucks. E-commerce company experiencing rapid growth expects a significant increase in traffic during next year's holiday season. Current platform struggles to maintain performance during peak times, leading to slow page loads, transaction delays, blah, blah, blah. Challenge is to redesign the platform to handle a surge in traffic, potentially up to 10 times the normal load, without compromising on user experience, transaction processing speed, and data integrity. Oh, there we go. This is great. Now we've got e-commerce in here. And one of the things that I remember talking about is the fact that when money's involved, now we need strong consistency. This is where we start to see transactions on our database. But putting stuff in the cart doesn't require strong consistency. That can require a very lazy kind of half slapdash sort of consistency model where, yeah, we got 1 billion of these things, put it in your cart. And then by the time you get to the checkout, I'm sorry, they're all sold. Sucks to be you. But that's a consistency model we can live with there. But the moment that we start charging your credit card, ooh, by golly, we need to make sure that we don't get very many actual failures because the cost of the failure at that point goes way up. So horizontal scaling, low latency, high transaction throughput are critical. Low latency actually imposes interesting restrictions. Some of the solutions we've talked about are not low latency. And so we may not want to use them. But we're going to have to balance that because in some cases, we're not going to be able to get faster latency because we have to have strong consistency. So there's always going to be that trade-off. This happens over and over again in distributed systems. The specific solution that we want to use will very much depend upon the problem we're trying to solve and the constraints on that problem. Cost effectiveness. We didn't really talk much about cost modeling, but when you get into the real world, oh yeah, every company on the face of the planet will have some bean counters there going, how can we cut costs? We can put less chips in that bag. We'll just leave it the same size. I don't know if any of you have noticed that. You go to like buy a bag of chips and you open it up. There's like 3 chips in the bottom. You're going, wait a minute, last week there were 4. They call it shrinkflation. You could become part of that solution. Time constraints. You have to get this thing done in time for the next shopping season. It's a little too short a time frame for it to be this shopping season, since this shopping season's already underway. You got almost a year. Blah, blah, blah. This time you're going to implement a system for supporting applications for a gym, a CrossFit gym. Anybody ever heard of CrossFit? Okay, high intensity interval training, blah, blah, blah. It's like a religion. So I have some requirements for this thing, right? It has to be community focused, because these are very social gyms and people hang out together and stuff. And but of course, the gym owner is mostly concerned about making sure that they have a steady flow of money, so there are financial transactions involved, and people pay for certain kinds of membership. And so every time they sign up for a slot, they have to make sure that they're authorized for that slot. So there's a whole payment authorization system here, but then there's also this social networking side of things. And then there's this record keeping side of things, because people like to keep track of their workouts and say, well, gee, I've improved. So on and so forth. So there's this list of requirements, and then we get some questions about this, because I don't care what the front end looks like, right? For this class, it could have a command line interface, and I wouldn't care. And nobody's going to use a web app that's got a command line interface on it, but I don't care, because I'm building the back end. I build the part of this that requires the databases and the consistency guarantees, and oh, we've got a messaging app in there. Gosh, what kind of consistency model do we need for that? Strict, right? Got to have a strict consistency model. Oh, we talked about this example. This is a read your own rights consistency model. Nothing worse than working with a chat app where your messages show up in the opposite order that you sent them. Ever had that happen? It's annoying. It's broken. You're like, wait a minute. I remember the fat guy told me, read my own rights. This didn't preserve read my own rights. It's a flaky distributed system. Yep, it is. Which consensus protocol might be suitable for ensuring strong consistency in the financial transactions database? Bloom filters. I mean, you have to throw in some easy ones once in a while. You look at that and you go, seriously? Why would you use a Bloom filter here? Primary backup replication. See, I did get rid of master slave there. Raft, two-phase commit, or Paxos. Blah, blah, blah. So you're going to see the same terminology. You're going to see the same kinds of questions. The questions are worth 1 point or 2 points for the true, false, and 3 points for the multiple choice. And that just reflects the fact that true, false questions really are a little bit easier than multiple choice questions. Look at the last scenario. All right. Now you are the lead database developer at GlobeChat. And you have to evolve the platform's database. So I picked this example because I said one of the problems I've talked about is this issue of how do you move forward? You've already got an existing system there. How do you evolve to the next phase of that system? How do you make sure that there isn't a 2-week down period while you upgrade your databases? I wanted to explore at least some of the questions around that. So we need to replicate, we have to have sharding, we need to have in-production database updates, because there's nothing more nerve-wracking than updating your database in production. Wow, how am I going to do that? Need to have performance enhancements. So how do I make this thing faster? Because the whole point is we're growing like crazy. You know, we're the next TikTok. blah, 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 and then we get into the question, right? You've decided to move away from fixed size records for usernames and allow variable size names with internationalized language support. Which technique would be useful in the database for improving the efficiency of space utilization for variable sized records? By golly, I really had to work to pull a couple of questions out of the first 6 chapters of Petrov, and this is one of them. That's probably about as specific a detailed example as you're going to get. That makes the question hard, but it's actually not a very hard question. Benefit of having multiple choices is that it can only be one of those things, unless I got it wrong. In which case it could be 0 or 2 or 3 or 4 or 5. I don't think any of them are going to have 5 correct answers. I hope not. You get really, really deep philosophical questions or statements like B trees are effective for indexing and query performance. GlobeChat needs to implement a data recovery mechanism that's efficient for a high transaction environment. What do we do when things go wrong? We need to reset our database, roll back an aborted transaction. How are we going to handle this? Yada, yada. And then you're going to get to page 49. Page 42, just to stick with my theme of always answering page 42. And that will be your extra credit opportunity, which is, at this point, I want you to go back and think about this in your exam and say, what do I think I'm going to get as a grade on this exam? If you can pick your grade exactly, you will get a 5-point extra credit bonus. If you can pick it within 1 point, you will get a 4-point extra credit bonus. If you can pick it within 2 points, you'll get a 3-point extra credit bonus, so on and so forth. And if you're more than 5 or more points away from your actual grade, you won't get any extra credit. I see people kind of laughing at that one a little bit. My goal was to actually make this a self-reflection activity right at the very bitter end, which is, okay, how good am I at actually gauging how well I did? And I'm going to see, and I think it'll be very interesting to see how many people are really close to their actual grade. And then, to tie this into the pre-class conversation, I looked at that and I said, well, this is kind of an interesting question. What is the best way for you to guess to maximize your possible reward? It's a game theory problem as well. I liked that aspect of it. There you go, and you get 5 points. Boom, and you're done. Yay, I got 5 points on my exam. Awesome. Or you could just randomly circle, just literally randomly circle and say, okay, well, there were 20 multiple choice questions, so I should have got 1 out of 20 of them, or 4 out of 20 of them. That would be 3 times 4, that's 12. And then there were 20 true-false questions, and I guessed on those, and so that would be 10 points. So I should get 30. And then you get 35 if you were right, statistically. It's completely different than the teacher question from last term. I think 20% of the people got the extra credit on the teacher question line. So at this point, I'm going to ask you if you have any questions. It's intended to be a somewhat difficult exam. Not mind-numbingly, horrifyingly, oh my gosh, but rather to try and test some level of understanding and how well I actually taught you these ideas and these concepts. There's a couple of difficult questions in there. There's quite a few that are easier. So I don't know. I suspect you'll probably do at least as well as the term 2 students last year. And they had 50 questions. Question? Anything you had a self-assessment on is fair game, including the cut through the last lecture. Yeah, because I actually said, you know, I think I put a question in here that was specifically about logging, because I think that's an important concept to understand. My goal isn't to like drill you on every single thing here. It is really to sample more along the lines of what we talked about. And when you go through these, that should be what you take away, is you should say, okay, well, this is a lot about, answering these is relatively easy if I understand the concept. That's my hope. So you need to show me I did a good job of teaching you by getting a good grade on this exam. Otherwise, I'll be disappointed in myself. I mean, I know you look at it as an assessment you have to trick, and I look at it as a how well did I actually get this stuff across. I wish I could say I did it perfectly, but I can already see ways I can improve next time. Probably suggest to me things that I can do to. Continuous improvement. Welcome to distributed systems. We never do it perfectly, but we keep trying to do it better. Sometimes we actually, and then sometimes we turn it into a nightmare because we overcomplicate things. Hopefully I haven't overcomplicated. Any questions? Any more questions? How many people are confident about this exam now? How many people are worried? You guys worry too much. Now, just like, go get drunk, go get a couple of joints or something, or whatever it is that helps you relax. Just come in and just sit down and breeze through it. 30 minutes, you'll be done. And then the pain will be over. And you'll go, and the beautiful part about it is then you can go study for all the other finals that you guys have. All right. Well, thanks very much, and I will see you next Thursday. Don't forget the capstone code is due next Wednesday. And then officially your capstone project is due on Thursday at midnight. But of course, I won't be looking at them until after the 22nd of December at 11 p.m. So you have until the end of 22nd of December to get them in late with no penalty. I love the game playing here. Let me stop the feed and bye, guys. A lot of people showed up tonight.